Hey everyone, my name is Yash Sharma. Here at Velotio, I work as a software engineer dealing with mostly cross-platform technologies like Flutter, and I've been doing it for past 5 years. Today we'll be discussing what is data persistence, how to implement it in Flutter, and what are push notifications and how to implement them using FCM in Flutter. We'll also look at the best practices for both of them. This is going to be a two-part video. So let's start.
Today we'll be talking about data persistence and push notifications in Flutter. They both of them are really interesting and important topics for mobile development in general. We'll be talking about what is data persistence and what are push notifications, how we can implement them in Flutter, and the best practices to follow while implementing them. So, what's data persistence? Data persistence in Flutter refers to the ability of an app to store and retrieve data across different user sessions and device users. Let's understand this with an example. Consider an app where the user can do three things. The user can sign in, the user can set a preferred language, and the user can set a preferred theme. Now, once the user has made these changes and exited the app, without data persistence, there's no way of keeping track of them. So it will result that when the user opens the app next time, the preferred language will be set to default, the preferred theme will be set to default, and the user may even be signed out. This will surely lead to a bad user experience and can be avoided using data persistence. Now, data persistence can be implemented in different ways in Flutter, each having its own advantages and moreover, each having its own usage. You can implement data persistence using shared preferences, SQLite, and file storage. Let's look into each of them. Shared preferences. Now, shared preference in Flutter is a key value storage mechanism that allows apps to store and retrieve small amounts of data persistently on the device. It provides a simple, lightweight solution for storing user preferences, settings, and other small pieces of data that need to persist across app sessions. By utilizing shared preferences, developers can easily persist and retrieve small sets of data within their apps, enabling the preservation of user experience and settings across multiple sessions. Now let's understand this with another example. Consider you have a note-taking app where the user can create and uh, delete and maybe even reorder notes. Now, with shared preferences, you can give the user an ability to set individual color and theme to the notes. We'll be able to assign a value to each note and save it locally in the device. So whenever the user opens it, we can fetch that particular key value from the database and show the correct theme to the user for that particular note. This will ensure that the user will get a smooth and a really pleasing user experience while using the app. Now, keep in mind that shared preferences can be used to store primitive data types like integers, booleans, strings, and a list of strings. We cannot store structured or uh, complex data structures. Rather than cannot, it's advised to not store these things in shared preferences. So for these, we use SQLite databases. Now, SQLite database is a local, lightweight, and relational database that allows apps to store and manage structured data. It provides reliable and efficient solution for persistency and storing and querying large data sets in Flutter applications. By utilizing this, developers can create robust applications and can efficiently store and manage structured data. This enables the app to work seamlessly even without an internet connection and provides flexibility in handling complex data scenarios within the app. Now let's take an example of a messaging app. Now in a messaging app, the user can send messages, retrieve messages, and can chat with other people. Now, if we have SQL-like database in the app, we can ensure that the user will have access to all the messages in the past without even being connected to the internet. For example, we can store the messages that the user has sent in the past in the SQLite database and query them whenever the user opens the app. This will lead an experience that the user will be able to access the app, view its past history without being connected to the internet. The best example of this is WhatsApp. We can use WhatsApp app even when we are not connected to the internet. Next is local file storage. So file storage in Flutter refers to the ability of of a Flutter app to read from and write to files and devices local storage. It enables apps to store and retrieve various types of files such as images, documents, logs, and any other file format required by the application. By utilizing file storage in Flutter, developers can handle various file-related tasks such as saving user-generated content, caching files, logging data, etc. A common use case for local file storage is handling file-based operations such as saving, reading, and managing files within the application. A correct example for this would be a document scanner, where the user can scan the document and convert it into a PDF. Using file storage, we can ensure that the user will have access to these files even if they are not uploaded to the cloud. The user can send this file to another device and access those files in that device. This will lead to a good user experience, and in short, data persistency will help user to access the same files even without being connected to the internet or without even being using the same device.
So today we looked into what is data persistence, why do we need it, and how to implement it in Flutter. We also looked into different data persistent techniques and when to use them. In the next part, we'll start with push notifications and the best practices for push notifications and data persistence. Thank you.